All right, so now that we have our handy dandy chart and we know how to use it and what it means, we can use it to start tackling some schematics. We'll start off with the easy ones. We'll move up to some super complex ones, but we use these rules and these equations to help fill in the blanks and find some missing measurements that we might be looking for in a particular schematic we're looking at. So we're going to start with schematic number 1. And so we've got 3 resistors here, and we're going to use some context clues. There's a lot of information on here, but we can see that with each of these resistors, we've got an A, a B, and a C, right? So a voltage sub A and a current sub A, a voltage sub B and a current sub B, voltage sub C and a current sub C. So that's kind of telling us that they want us to call these resistors A, B, and C. Right? We'll just keep it consistent, RA, RB, and RC. And then up here, the supplied voltage is coming from a battery, it looks like. So they're using, instead of V supplied and I supplied, using VBAT and IBAT. A few less letters, a little bit easier, so we'll go with that. But the first thing to do is to classify how the resistors are wired. So if we look at these 3 resistors, how would you classify them? Yeah, they are wired in series. We can see all 3 of these resistors are wired into the same branch, which means same branch, same path of current, series. So the first thing we can say is that RA, RB, and RC are wired in series with each other. So if we go to our handy dandy chart here, we can see that that means that we're going to be living in this column here. We're only going to be concerned with these 2 patterns on the left. Now, when you're going to solve a circuit or fill in the blanks with the different measurements, it usually won't really matter if you start with the voltages or the currents. Usually you'll get a complex schematic and say, fill in the blanks. And it won't really matter if you decide to do voltages or currents first. I would recommend starting with 1 to try to find all the voltages before you try and find all the currents. That way your brain doesn't have to keep shifting gears and looking for the patterns, because the patterns do flip-flop. Now, that's not to say that you can go in necessarily any order you want, right? Because if you decide to look for some voltages, you might have to solve for some voltages before you can solve for the others, or some currents before you can solve for other currents. But typically, it won't really matter too much if you decide to go voltages first or currents first. But pick a path and stick with it. I like voltages better. I think they're a little bit more intuitive, so that's what I'm going to do. When you do these on your own and you have free reign, feel free to choose whichever makes more sense to you. So here I can see I've got the voltage that each resistor is getting, but I need to find out how much voltage we're supplying from the battery. Well, if we go to our chart here, we can see this is the equation we're going to be using. The voltage supplied is equal to the sum of the voltages. So in this case, the voltage supplied is VBAT, and the voltages are the resistors. So that's going to give us this equation here. VBAT equals VA plus VB plus VC. And you can see now we're starting to get into our 3, 4, 5, right? So here's our picture. So it's still 5-step math, except our picture and variable list are all kind of combined onto one thing here. And now we're going to do our 3, 4, 5 math. But since the math is going to be very, very simple, and I'm basically giving you steps 1 and 2 all together, I am going to ask for a little bit more with you showing your work and looking at it this way. So give me justification for why you're going to choose the equation you're going to give. It might seem more like overkill now, but once you get into the more complex circuits, it's going to be kind of a lifesaver. So what we've got here are A, B, and C wired in series with each other, so that allows us to use this. And then we can just, that's step 3. We got our equation. So step 4 is plugging in those numbers, putting them right there. They gave me whole numbers on the list, so that's what I'm going to round to is whole numbers. And then we get our VBAT is going to be equal to 12 volts. And then we're all set. And that's all of our missing voltages. So now we can try and tackle the currents. And in series, we know that current is just straight up equal. So, it does not depend on the resistance or anything like that. Just all things wired in series are going to get the same amount of current flowing through them. So we can apply that here by saying that, the current through the battery is going to be equal to A, equal to B, equal to C. And we can say that here because there's really only one branch that the battery is supplying current to. If there were multiple branches, well, then that would be a little bit of a different story. And we'll look at that in the next video. But for now, we can just say IBAT equals IA plus IB plus, IBAT equals IA equals IB equals IC. And since there's 0.65 going through the battery, it means there's going to be 0.65 going through everything, through all of those. So you could write this out as a big, long, complicated, mini essay, or you can just say They're wired in series. So this math, done. Call it a day. That's all there really is to it. So I'm going to give you another example so you can use this as a guide here. What I'd like you to do is try and tackle this one. See if you can't fill in the blanks there. Try to use the same pattern for showing your work. Give you a second. You can pause it to write it down, and you're going to type this into Edpuzzle, so, with your justification as best you can. If subscripts are too hard on Edpuzzle, don't worry about it. Just you can just type in VBAT, all is one word, equals VA. That's not a big deal. But do try to enter in your work kind of just like this. So we'll take a minute. We'll pause and go ahead. Yeah, it's going to be way too long. I'll just pause it right here. All right, so let's take a look at what our results are. So they're going to be very similar to here. And there we go. Again, all three resistors wired in series. So again, you know me. I like tackling these voltages first. So I know that the voltage supplied is going to equal to the sum of the voltages. So VBAT equals VA plus VB plus VC. We know we're supplying 9 volts. We got 1.5 across A, 2.5 across C. So we are going to add it up like this. And do please, break your work down into these simple steps. Right? I've told you 1,000 times, the simpler the math is, the more likely you are to make a mistake when you start to combine steps in your head. So the more you put on paper, the less chance of a mistake you're going to make. So please show your work like this. Get it over here. You don't necessarily have to show your algebra for this, unless you find that really helpful. But that'll get you there. And then we know that current is just straight up equal here. Don't be tempted to add up the currents because these are wired in series. So just all straight up equal to each other at that. Pop, pop, pop. And there you go. That's all there really is to, fill in the blanks in series. Pretty simple. Next, we'll take a look at how we would show this work for things wired in parallel. And then we'll get into some really juicy ones. So stay tuned.